This is Official Nerd Business. Hello nerd boys and girls, welcome back to our regular programming. We are once again looking at Euler problems and using Python to solve those. Today we are at problem number 13, which is titled Large Sum. As you can see on the screen, I've already copied in the problem description. I've built up the template file as I usually do, and let's have a look at the problem here. Work out the first 10 digits of the sum of the following 150 digit numbers. I have copied those numbers into a variable called big block, which is a big block of all the lines with all the numbers, so each line has 50 digits. There is 100 of these numbers, and we are interested in what happens when we take the sum and then the first 10 numbers of that sum. So it doesn't sound too hard. Let's see what we can do here. I have made the number we want out of the front of the result as a parameter, so we can play with that if we would want to. But let's see. We have a big block. And we want to split that, I guess, on the new lines. Which are the line breaks, so the enters between numbers here are specified by /n for new line as a special character. We've gone into that in the previous video. So this should give us every number on its own line. Then we could use that mapping function again that we also used in the slicer. Now if you're unsure on how the syntax works for that, we can simply look it up. So here's the library file. It's this one, yes. So here we use the mapping function to create ints of whatever we put into it. I say that's a very valuable piece of code, so let's use it here, and instead of the list we're gonna insert just this entire list on itself. And we should be able to simply sum this. If we were to take the entire thing, we get an error. We also get an empty element because there is a new line behind this, and that should easily be corrected. Now we are not interested in the entire number, but we are interested in the first 10 characters, so we can take those by converting it into a string, and then slicing that string, which basically is a list up, taking a slice of 10 characters of the front end. So if we rerun this, then we get the correct answer. So this is a particularly easy problem, but it's meant to show you some basic arithmetic, because we could solve this not by adding 50 digit numbers but only the first 11 numbers. However, if we want to do that, let's see, let's run this through main so we can get the timing information. Here we go, and there we go, and then we want to run number 13 with the basic parameter. Oh, I'm not returning it yet. I'm printing it and not returning it. That's bad. It took us virtually no time at all. Now I've researched this problem a little bit. I thought, am I missing something? This is just too easy. And I came across a couple of people using solutions that were slightly different in that made the numbers, though we didn't map them to int yet. So let's undo that bit. Then it did something along these lines, where it added to the running total the took a slice of 11 characters, because last character might carry, and it converted this into an integer and then added it to the running total, and then here should be good. So if we run attempt number 2 instead of attempt number 1, should be getting the same result, but we'd be doing less math because we are adding only 11 numbers per number instead of the full 50. Oh. Focus. And although that's true, and although this doesn't actually show up in our timing information here, but this solution, this approach is actually slower than just adding the numbers. The operation here where we chop off a bit of a string and then convert that to integer and then add it to our running total, especially this bit, is simply slower than simply adding the numbers all together. So here it's a bit penny wise pound foolish for speed, for optimizing, though on this relatively small selection of data it doesn't really hurt us too much. But those are two approaches you can take for doing this. There is a third approach I want to discuss, and it's a bit of a technicality and not so much on the mathematical side. Say for instance that we didn't save this entire block of data in the Python file here, but say we made an extra text document, a .txt file where we stored all of this. I made a new folder under under the base directory of our solution, and it's called resources. And in resources I now have one file which is called 13.txt, which contains all the numbers here, and I have placed a file called resources.py which handles reading files from this directory. I will go into what this does in a second. For now I will close it and I will create a third attempt where we get the data not from the block here, but from reading the file. So I need an import for that. And I could say our numbers, not enumerate, numbers, sorry, typing is very hard, is our .read file and 13.txt. Now the numbers variable is basically the same as this one, so we should run, in fact we should do this instead of copying from solution number 2, as this said before. This is faster. And basically we have solution 1 again, so we can just do this. So let's run attempt number 3 and see if everything is still hunky-dory. I will run it from this side instead of through main. It is not. Oh, because I have once again copied in that final enter into this file. Apparently, yes. So if we remove that, so there we have the answer once again. So now we have a resource manager that reads files for us as long as we save them in the actual resource directory that we've created in the base of our solution. So for later challenges we can simply create whatever text file we need there, plug it in, then run this. Maybe we can add an option to automate this bit. But let's take a look at the resource manager for a second. Why did I create a separate resource manager when the entire statement that we are interested in is basically just this? So this is file IO in Python. It's particularly easy. We just say that we want to open a file, then we give up the file name we want to open, and I'm doing some complicated stuff here. We could basically just say with open and then a file name with a relative path. We had 13.txt for instance. So X is now a file link to this, and we can say some things to access it. I'm using f here for instance, and I say fread, so that gets all the contents of the file and puts it in one variable, and here that value gets returned. We could store it in some variable, and now we have a string value with all the file's contents in here. There's different ways in which you can read a file. You can read it line by line, for instance. You can read certain chunks. You can do whatever you want through manipulating this function. I will put a link to documentation in the description. Why did I go out of my way to create a separate file manager? Well, we have to deal with we need a file name, and a file name also contains a bit of a path, and the path might be relative or absolute, and I like to work with relative file paths, but that does mean when we run this through the main py, or we run it through the solution file itself, which are two valid options in our setup, the relative path might start out from the lowest possible level or from our solutions folder. So we don't have one definite link to our file. If we save those in resources, it might be in our files might be in this directory, or they might be in this directory. Depending on whether or not we are in the main or in the solutions folder. So this is a bit of a relative file path that say go up a directory and then enter this particular directory. So to counteract that, I've created this little bit. It reads a file, you give it a file name and only the file name. It assumes that the file itself is in the resources directory. Then we get the path of this current file, so that's resources py, and that's inside of the resources directory. And then we want to open a file, and when we take a look at our own file name, we replace the extension indicating resources py, and we replace that with whatever file we want to open. So that makes this that makes sure that this relative path always points to the right file, independent of from where we call this function. So that's basically all this does, and we will certainly be using this in future Euler videos, Python videos, when we will also be onboarding this little bit into the other file, because it's just annoying. So yeah, a pretty simple challenge that gave us the opportunity to look at some more technical side of Python, in this case file handling, which will come in handy later. I will see you next time for problem number 14. Thanks for watching this video on Official Nerd Business. Don't forget to like and subscribe and click the bell icon. Did we discuss everything you wanted to hear, or did we miss anything? Any topics you want to hear in ONB? Leave your thoughts in the comments. See you next time.